Third properties which we are talking with respect to the transistor is the width of a depletion region. So I'm writing here width of a depletion regions. So here what we have to see is that whenever we are talking about the ammeter, base and collector, so I'm drawing here. So let's say I'm writing here my ammeter, I'm writing here my base, and I'm drawing here my collector. So I'm saying this is my ammeter and this is my collector. Okay. And for the visualization, what I'm doing is that I am doing it color. Okay, so this is my ammeter and this is my base and this is my collector. And what we have seen is that we have discussed that they will be having a junction. So we will be having a junction here. So this is my J1 and this is my junction J2. That means when we are talking about the junction, okay, whenever you have seen that whenever we have talked about the junction in the PN diode, so we have seen that there will be a junction. Okay, so the junction will be having some depletion layer with respect to the forward bias and reverse bias condition. Okay, so here also we are talking about the junction. So this is my junction number one. So we will say that here also we will be having a depletion layer. Okay, one is here and another one is here. And what I'm doing is that I'm writing this depletion layer as D1 and this is my depletion layer D2. Similarly, when we are talking about the junction J2, again we have got a depletion layer here. So I'm drawing a depletion layer here and I'm drawing a depletion layer here. So I'm writing the depletion layer like this. So this is the depletion layer, let's say I'm writing it as a D4 and this depletion layer I'm writing it as a D3. So what we have seen is that when we are increasing the reverse bias condition, we have seen that the depletion layer will going to increase. And what we have seen is that when we are talking about the forward bias condition, we have seen that the depletion layer is almost equal to zero. And one property which we have also seen is that when we are increasing the amount of a doping, okay, so I'm increasing the amount of a doping, then also we have seen that the depletion layer will going to decrease. And based on this, what we have seen is that ammeter is heavily doped, base is lightly doped, okay, and collector is moderately doped. So you will going to see that here we have got this condition that D1 is less than D2, and when we are talking about the junction J2, we will going to say that D3 is less than D4 because we are combining these properties of a reverse bias, that when the reverse bias is increasing, the depletion layer is increasing. So you can see that this, when we are comparing this D1 and D2 of a J1, this is much less than with compared to this J2. Whereas when we are also talking with respect to the doping, so we have seen that this ammeter is highly doped, then this collector is mediumly doped, and this base collector is lightly doped. So you will going to find that since this base is lightly doped, so the D4 depletion layer will be more when we are comparing it with respect to the D3. So here what we can write is that D1 is less than D2 and D1 D2 is much less than D3 and D3 is less than D4. So this is one of the important property of the width of a depletion region. And finally, we will be talking with respect to the biasing of each junction. So the fourth property which we are talking is with respect to the biasing of each junction. So when we are talking about the biasing of a junction, what we say that we have got a junction J1 and we have got a junction J2. Okay, so I'm just for the sake of understanding, I'm drawing here a again the transistor. So I'm writing here is the emitter, base and collector. Okay, and I'm writing here a junction J1 and the junction J2. Okay, and now we can see that, so depending upon the properties that how we are connecting these junctions, okay, whether we are making these junctions as a forward biased or we are making these junction as a reverse bias, we can set the mode of operation, and according to the mode of operation we can talk about the applications of the each transistor. Right now we will be not talking about in much details that what will be the mode of operation, but we are trying to give you the overview of how these junctions can be connected. So what I'm trying to do here is that we are making these junction, okay, and here we are saying that when we are talking about these junction and J1 and J2, we are also talking about the mode of operation, and then we will be talking about their applications. So depending upon this junction J1 and J2, what I can say that I have a junction J1. So this J1 can work as a forward biased, and this junction J1 can also work as a reverse bias. That means I can make the connection of this junction J1. Similarly, I am talking about the J2, so I can make this junction J2 as a forward bias and I can make it as a reverse bias. So we will be getting the biasing of a each junction. So biasing means that when you are connecting this emitter, base and collector with the batteries, okay, and you are providing some operation to it, okay, and when we are not connecting it with the batteries, what we say it is a unbiased, or we can say it is an open circuit. So we will be seeing that we can have a four combination of this. I'm writing here number one, two, three, and four. And let me talk about the first one. So the first one we are saying that junction J1 is forward biased and junction J2 is reverse biased. Okay, so we say this mode of operation as a active mode. Okay, we can say that transistor is working in a forward active mode. And the application which we are using it is as an amplifier. So I'm using it as a amplifier. The second property which we are talking about is that I want to make a junction as a forward bias and I want to make a junction J2 also as a forward bias. And when we are talking about this forward biased J1 and J2, we say that the mode of operation is known as the saturation region. So your transistor is working as a saturation region. And when we are talking about this saturation region, we say that we want to use it as a digital switch or we want to use it as a digital device. Similarly, when we are talking about the that I want to make a junction as a reverse bias and junction J2 also as a reverse bias. So at that time I will going to say that the mode of operation is the cut off region. And again, in this also we will be using the same application, that I want to use it as a digital switch or I want to use it as a digital device. And finally, we have got a last stage of junctions. So we are saying that it is reverse biased and it is forward biased. So we have done the forward bias reverse, forward forward, then reverse reverse, and then reverse forward. Okay, so here we are saying that now we have inverted the mode. So we have reversed the active mode. So it is known as the inverted mode, or sometimes we say it as a reverse active mode. And here we are using it again as an amplifier with low gain. Okay, we will going to talk about it in more details as we will going to proceed in the upcoming lectures.